this video is for the linear inequalities notes. Okay, so we've done a little bit of this. We've solved inequalities, but we're going to start graphing them and finding equations when we have systems of inequalities. So, a linear inequality is a relationship with a constant rate of change represented by a solution set denoted by the graph of a line that may or may not be included in the solution and the set of points above or below the line. That is a long definition. So let's just start out with, what does it look like? All right, so less than. Less than, we're going to use this symbol. And then on the graph, what that's going to look like is a dashed line with shading below the graph of the line. So I'm just going to draw a line through the origin here, and I'm going to draw a dashed line. Okay, so a dashed line. And then we're going to shade it. Let me grab a map color here. We're going to shade below the line. All of those points are less than that equation. And so right now, all we need to focus on is identifying what the different symbols and on the graph looks like. But we would shade it down here below the line. Okay, so I'm going to go real quick on the shading so we don't make a real long video here. So everything down here would be shaded. All right, so greater than symbol, okay? So same thing, it would be a dashed line, but we would shade above the line in this case. So we're still using a dashed line. And we would shade above this line in this situation. Okay, so less than or equal to, here's our symbol. So for less than or equal to, we're going to use a solid line. And so this is just like when we graphed equations. This is just graphing inequalities now. So this one would be a solid line, and we would shade below. Okay. And then greater than or equal to would be a solid line again. Okay, but we would shade above this line. Okay, so that's just what the graphs look like. So now, solutions, verifying solutions. So if an ordered pair lies in the shaded area or on a solid line, it is part of the solution set. So if they give you a graph like this, we've got a solid line and it's shaded down here, and they would say, is -4, 3 a solution? I would go to -4, 3, whoop, up here. And that would not be a solution because it's not in the shaded and it's not on the line. Here we've got, is 1, 3 a solution? So 1, 3. So that one is on a solid line. So yes, that one would be a solution. Any point that falls in here would be a solution to that inequality. So on this one, it says is 2, 2 a solution? So 2, 2. Yes, that one's in the shaded area. And then 6, 2. Now this one is a dashed line. If it falls on a dashed line, then it's not a solution. So it has to be on a solid line. Okay? If the point lies on that dashed line, then it's not a solution.